Hi guys. So today we're going to look at some applications of vectors. And this is where it may be some stuff similar to what you may have seen in physics. We're going to talk a lot about force, and we'll also look at some maybe with wind speed and wind direction. So we're going to look at a basic example first to kind of figure out what's happening here. So you have three forces that are acting on an object, and it gives the component forms there. So let me kind of draw out a little bit what's happening here. So I have the vector 2, 3, which if I start at 0 goes this way. But again, since it's acting on the object, I'm just going to make the object here at 0, 0 to make it a little easier to see. So there's vector 1. I've got 8, negative 2, which normally goes out this way. But again, since I'm acting on the object, I'm going to just shift it to where it's going into the object. And then negative 2, negative 5, which again, normally going, this way, I'm going to shift it to where it's acting on the object. I've got three vectors that look like this. Since all three of those things are going on the object, to figure out what's actually happening, what the resultant is, I'm going to add all those up together. Now, again, graphically what's happening, if I were to add them, I would add them head to tail. So I would kind of take, and again, if you have notability, it'd be a little easier to just grab that and shift it over. But I don't have notability, or I'm not using notability on this, so it's a little harder to see. So what we're going to do is we're going to add these all up. So 2, 3, 8, negative 2, and negative 2, negative 5. If I add them all up, I'm going to get a component form answer of 8, negative 4. So what that is the component form of the resultant vector. Well, now we're going to find the magnitude and direction, because that's what's going to actually make sense for a lot of these applications. Remember, magnitude is Pythagorean theorem. So 8 squared plus negative 4 in parentheses squared. So that would become simplified 4 square root of 5. Okay, be the square root of 68. And, square root of 80, which simplifies to 45. Then we find our angle. The direction is tan inverse y divided by x. So y is negative 4 over 8, which actually is not under unit circle because it's tangent. So we'll use a calculator to figure this out. And I'm going to get a negative 26.57 degrees. So that is my magnitude and direction. We don't need to add 180 because the y is negative. 8, negative 4 would be over here in the fourth quadrant. So then we're also going to look at what's called equilibrium. So what that's saying is what's happening here on the box, okay, is this box has a vector component form of 8, negative 4 being pushed on it. So again, if the box is at the origin, okay, it would be like that if that's the origin. So we just took that and we just moved it around. So the one that would produce equilibrium, basically keeping that box from moving, would be the exact opposite vector. So the opposite vector is going to create equilibrium. And the opposite vector here would be negative 8, 4. So now let's look at some more word problems. It's going to use a similar concept, but we're going to look at kind of a more specific scenario. So we've got Mo and Joe pulling a wagon down the street. Mo is pulling with 28 pounds of force at an angle of 28 degrees, and Joe is pulling with 36 pounds of force at 43 degrees. We want to know the resultant direction and magnitude. So what we need to do is figure out component form first. So let's take Mo. The pounds of force that Mo is using, that's his magnitude. Okay, the magnitude there is 28. The angle is 28 as well. So we're going to find the component form. So we're going to do magnitude, cosine, angle. And for the y, we would do magnitude, sine, angle. It's kind of convenient that they happen to be the same number this time. So we can go ahead and plug that in. We have to use a calculator on this. That's going to be 24.72 for the x and 13.15 for the y. All right, now let's figure out Joe. We're going to find his x coordinate, or his x component, 36 pounds of force, so 36 cosine 43, 36 sine 43 for the y. Plug those into a calculator, 26.33 for the x component, 24.55 for the y component. So now to find the resultant vector, what we do is we add those two together. So if I take Mo's component plus Joe's component, that's going to be the resultant. So my resultant here is going to be 51.05, not plus, sorry about that, and then add our y's together. That's going to give us 37.7. Now we know the component form. But again, in order to actually answer our question, what makes sense in the real world for these is talking about the direction and the magnitude. That's the same thing we've been doing these past couple days. Magnitude is Pythagorean theorem. 51.05 squared plus 37.7 squared. Plug that into a calculator and you get a magnitude of 63.46, which is going to be the pounds of force that we're talking about here. Direction, we're going to do tan inverse y divided by x. So that is going to give you 36.45 degrees. So your resultant here of these two boys pulling that wagon, they would be pulling with 63.46 pounds of force at an angle of 36.45 degrees. All right, let's look at another one, very similar but slightly different. Instead of knowing the specific angles, we're going to know the angle in between them. So two forces, one has 52 pounds of force, the other is 75 pounds. There's an angle of 100 degrees in between them. So since we don't know the actual angle, what that means is we get to pick what those two angles are. So I'm going to pick the two easiest angles I could pick. I'm going to use 0 degrees and 100 degrees. So let's find the first one. It doesn't matter which one's which, we're going to end up with the same resultant, whichever way we do it. So I'll go ahead and make the first one. We're going to do 52 pounds of force. So for my 52 pounds, x would be 52 cosine 0, y would be 52 sine 0. Again, you could use your unit circle values for this, but I would get 52 0 as my component form. Now let's find our other one. We know it's 100 degrees away, all right? So 75 pounds of force. So 75 cosine 100, 75 sine 100. Plug both of those into a calculator. Negative 13.02 and 73.86. So just like we did in the last question, we're going to do everything the same at this point. We know our two forces, or two component forms. Let's add them together to get the resultant. So 52 plus a negative 13.02 is going to give me 38.98. 0 plus 73.86 is 73.86. So that is your resultant's component form. Now let's find magnitude and direction. Magnitude, Pythagorean theorem. 38.98 squared, 73.86 squared, square root it, plug it into a calculator, 83.51 pounds of force. Let's find the angle. We're going to use tangent, tan inverse y over x, 73.8, I'm having a hard time writing today, 73.86 divided by 38.98, tan inverse here, and I'm going to get 62.18 degrees. I do not need to add 180 because I have a positive x here. Okay, that would be in the first quadrant. So I'd be at about a 62 degree angle somewhere in there. And that is your resultant magnitude and force. All right, if you feel comfortable, try this next one on your own. It's going to be a very similar setup to the one we just did. All right, so what we're going to do here, very similar. Mrs. Baker and Miss Grimmett are fighting over a pre-cal book. Of course, because why not? So one of us has 46 pounds of force, the other has 40 pounds of force. There's a 58 degree angle in between them. So we're going to have one of them be 0 and the other one be 58. So I'll just do 46 here at 0 and 40 over here at 58. So we'll find the first one, x equals 46 cosine 0. Y equals 46 sine 0. Again, you don't have to use a calculator here. Those are some unit circle values. Remember, cosine of 0 is 1. So your resultant vector for Mrs. Baker, let me go ahead and label me. Resultant vector here would be 46, 0. Let's go ahead and find Miss Grimmett. So x equals 40 cosine 58. 40 sine 58. Plug that into a calculator. You do have to use a calculator on that one. I'd get 21.2 for the x and 33.92 for the y. Let's find the resultant vector. Let's add them together. That's going to give me a resultant vector of 67.2 for the x and 33.92 for the y. So again, to actually answer our question, we need magnitude and direction. So let's find our magnitude. Pythagorean theorem, 67.2 squared plus 33.92 squared. And that is going to give me, plug that into a calculator, 75.28, and then n is newtons. So newtons of force, or pounds of force. I don't know why I put newtons. That one's just force. All right, now we'll look at the degree. So theta is going to be tan inverse y divided by x. There is no negative, so it's just going to be whatever answer the calculator gives us, which again should make sense. If the angle is 58 degrees, it's going to be in between those. Plug that into a calculator and you get 26.78 degrees. All right, so the last ones we're going to look at are going to involve direction. So it's a similar process. The picture might just be a little harder to draw because we're going to start talking about directions. So a plane flies 62 degrees west of north with a speed of 310 miles per hour. There's a 25 mile per hour wind blowing at 13 degrees north of east. Find the plane's resultant speed and direction. So what's harder about this is that 62 degrees west of north isn't necessarily 62 degrees. So we're going to want to draw this out. So think about a compass. Here's north. I'm going to go 62 degrees west of that, which means this part is 62. Well, if that part is 62, that whole actual angle that we're talking about there would be 90 plus 62, which means it's 310 miles per hour for a magnitude, and my angle here is actually 152 degrees for my plane. Now let's look at the wind. Okay, my wind is going to go 13 degrees north of east. So here's east, 13 degrees north. Well, that's pretty easy. That's just regular old 13 degrees. So let's find our component forms. We'll start with the plane. So x is going to be 310 cosine 152. Y is going to be 310 sine 152. You have to use a calculator on these. I get negative 273.71 and 145.54. My wind here, I would do 25 cosine 13 for x, 25 sine 13 for y. Plug each component into a calculator, 24.36 for x and 5.62 for y. Now that I know my two components, let's add them together to get our resultant. So where this plane is actually, what the distance it's traveling at the angle it's traveling based off that wind. So what we have is our, 24.36 plus negative 273.71 is going to be a negative 249.35. Let's do the y's, add them together, 151.16. That's our resultant. Magnitude, Pythagorean theorem, put that negative in parentheses. Plug that into a calculator, you get 291.59 miles per hour. To find the angle, we'll do tangent inverse. So tan inverse y divided by x. This time our x is negative, so be careful. Remember that you have a negative x. We do have to add 180. And when I do that, I'm going to get 148.78 degrees. And that's the result of the plane. Now, if you think about it, it makes a little sense. Okay, the original one was 152 degrees. That wind's not going to make a major difference here on our plane. Okay, it's still flying about the same direction overall. All right, we're going to do one more involving direction. Again, very similar. We just have to consider these directions when we write our angles here. So two players kick a soccer ball at exactly the same moment. One player's foot exerts a 66 Newton force at 50 degrees east of south. So south will go east 50 degrees. So let's find what that whole angle is before we move on. So if I start at 0 and I go around, I would do 180 plus 50, or I could start at 0 and go negative 40, whichever way you want to do it. I'll just use negative 40 because that's faster. So here's soccer player 1. He's got 66 newtons of force at negative 40 degrees. All right, let's find player 2. Player 2, he's got 88 newtons of force, 20 degrees east of north. So here's north, 20 degrees east of it, there's 20. If I start at 0 and move over there, I have moved 70 degrees. So now let's find our component forms. 66 cosine negative 40 for x, 66 sine negative 40 for y. I can plug those into a calculator and get a component form of 50.56, negative 42.42. Let's do player 2. 88 cosine 70, 88 sine 70. Plug them into a calculator. 15.28, 86.66. And those are your two component forms. Now that we have our component forms, add them together. Add my x's, that's going to give me 65.84. Add the y's, 40. And before I go too far here, I realized I typed this in wrong, so let me adjust that. 88 cosine 70. 88 cosine 70 is going to be 30.1. And then 88 sine 70 is going to be 82.69. So those are my component forms. Sorry about that. So now let's go ahead and add those together. All right, so my resultant here, 50.56 plus 30.1 would be 80.66 for the x. Negative 42.42 plus 82.69 for the y's is going to be 40.27. So that is your resultant component form. Now let's go ahead and find our magnitude using Pythagorean theorem. 80.66 squared plus 40.27 squared, square root it, and I get a magnitude of 90.15 newtons on this one. Let's find our angle. So tan inverse, we're okay to keep it how it is because we've got positives for our x, so it's going to be in the first quadrant. So we've got y divided by x, 40.27 over 80.66. Plug that into a calculator, and I get a 26.53 degree angle. All right, so again, sometimes these word problems can sound difficult. Again, we're doing really the same process every time here. If you don't have the component form, find it. Add them together to get your resultant, then find your magnitude and your angle. It's a lot of the same stuff we've been doing, just in a word problem form. The only time it gets really tricky is when we start talking directions, and if that's the case, draw the picture in order to be able to find what that angle actually is.